Now let me do this limit by two methods. The first method, which is also most commonly used method, we let this be y, the limit be y. First, I change this secant into cosine. So this one becomes the cosine x to the negative 1 over x squared, right? Now, since this is an even function, therefore x goes to 0, doesn't matter which side. Both sides are the same. So then log y will be equal to the limit x goes to 0, negative 1 over x squared times the log cosine x. And as x goes to 0, cosine goes to 1, log 1 goes to 0. This one goes to infinity. Therefore, this is indeterminate form. We can use L'Hopital's rule, right? This is negative log cosine x and x squared. Well, both goes to 0. Therefore, L'Hopital's rule can be applied. This is the limit x goes to 0 and negative. This is 2x. Log cosine is what? Log cosine is a tangent, right? Tangent x. Well, the cosine is negative cosine. Yeah. Then this one is equal to log tangent. Okay, cancel negative. Then this one is equal to the limit becomes sine x over cosine x times 2x. And sine x over x, when x goes to 0, equal to 1, right? So this one equal to the limit x goes to 0 is equal to 1/2. Okay, this goes to the 1. This one with that one is also 1. This is the half. Therefore, y is equal to e to the half. Because y is equal to this. Log y is a 1/2. Y equal to this, which means our limit, which means equal to the square root e, right? Therefore, the limit goes to 0. Secant x 1 over x squared is equal to square root e. Okay, that is the first method, which is easy. Now mainly I want to discuss this question by second method, in which we don't use L'Hopital. Okay, let me do this one. The limit x goes to 0, secant x 1 over x squared. Okay, now first I change the secant to cosine, right? This is the limit x goes to 0, cosine x to the negative 1 over x squared. Okay. Now, before I continue to do this limit, let's recall something. Where does E come from? E is this limit. Something goes to 0, 1 plus something to 1 over something. This is something could be single variable or a function. So this limit is E. Or there's another way, which is something goes to infinity, 1 plus 1 over something to something. This is also E. Okay? This show that where E come from. Now let me continue with this one, all right? I use I try to create this formula. This means the limit x goes to 0. I need a 1, right? 1 plus cosine x minus 1. Right? Negative 1 over x squared. Let me change the pen. All right. This one is equal to the limit x goes to 0. Let me use a color. This is a 1 plus cosine x minus 1 to the power cosine x minus 1 and cosine x minus 1. Yeah. All together to the power of a negative 1x squared. And the red one is my star. The red one is my star. Therefore, it's equal to E. You know why? Because when x goes to 0, cosine x minus 1 is going to 0. So which means this one goes to 0. Therefore, this is equal to the limit x goes to 0 and E. This is my E, right? E to the power cosine x minus 1 negative x squared. Okay. Now, if I'm allowed to use the L'Hopital's rule, I can finish easily, take a derivative and so on. Suppose that I'm not going to use the L'Hopital's rule. As I said, second method, we are not using L'Hopital. Then what to do? This one is equal to the limit x goes to 0, E. Cosine x minus 1 is a negative 2 sine square half x. Isn't it? Yes. And I want to create half x. This means half x square. And this is x squared over 4. That times 4, right? Times 4. This one is equal to the limit x goes to 0, e, negative cancel out, right? 4 over 2, 2 over 4 is half. And the rest is that sine half x over half x to the square. As x goes to 0, sine x over x, sine something over something, something goes to 0 is 1. Therefore, this one is equal to e to the half. Therefore, well, this is finished, right? No more therefore. All right, that is the end of limit. Okay, so this is the method now without L'Hopital's. Okay, hope you like it. Thank you.